Hello and welcome. You might have noticed in examples 5 and 6 that there was symmetry about either the x-axis or the y-axis when we drew our pictures. Example 5 had symmetry about the x-axis, example 6 had symmetry about the y-axis. So I wanted to talk a little bit about symmetries and when they come up in polar equations, because it can help you when you're graphing a polar equation. If you know that there's symmetry, you only have to draw half the graph, and then you can know by symmetry what the other half of the graph looks like. So if you can get back to the original equation after replacing theta with negative theta, then the graph is going to be symmetric about the x-axis. In other words, if we draw a little picture of a coordinate system, and if you can plug in theta and get a point on the graph, or the negative of that theta and get a point in the graph, well, then you're going to have this symmetry about the x-axis. This is like a theta, and this is negative theta. Kind of hard to see that. There, that's better. So if you can plug in theta and negative theta, and they both give you points on the curve, then there's going to be symmetry about the x-axis. You can replace theta with pi minus theta, then you're going to have symmetry about the y-axis. So if you plug in a point, so if you plug in like an r theta and it's a point on the graph, and you're able to replace that theta with a pi minus theta and still get a point, pi minus theta would be the one that's just across the y-axis. Right, if this is theta here, then pi minus theta would give you, by symmetry, another point that's just opposite the y-axis. So then you're going to have this symmetry about the y-axis. And lastly, if you replace r with negative r, then the graph will be symmetric about the origin. What that looks like is this. If you've got a point on the graph over in the first quadrant, and you replace that r with a negative r, and you still have a point on the graph, then you've got this symmetry about the origin. Symmetry about the origin you can think of as being rotating by 180 degrees, and you still have a point on the graph. Now, some useful trig identities that can help you out here when you're trying to figure out, does my polar equation have any symmetries, are cosine theta equals negative theta. Cosine of negative theta equals cosine theta. In other words, cosine is even, so it eats the negative in front of the theta. That can help you out because that says that it doesn't matter if you plug in theta or negative theta, you still get the same thing for cosine. So cosines will often have these symmetries about the x-axis. You can replace, so then sine of pi over pi minus theta equals sine of theta. That identity helps you with situations that are symmetric about the y-axis. So oftentimes sines are going to be symmetric about the y-axis because of that identity. These other two, the first and the fourth ones, I just put for reference, but it's really these middle two that help to satisfy these conditions of symmetry. So in example 5, which was r equals 1 minus cosine theta, we can see the symmetry about the x-axis by replacing the theta in that equation with a negative theta. If we replace that equation, theta with a negative theta, well, cosine of negative theta is just back to cosine theta, right? Cosine of negative theta is equal to cosine theta because cosine's even and it eats the negative. And since we got back to the original equation, we know that we have symmetry about the x-axis. So in example 5, we had symmetry about the x-axis. Now for example 6, if we replace the theta with a pi minus theta, it's not going to do anything to the equation because, as we just mentioned, sine of pi minus theta is equal to sine of theta. So we'll get back to the original equation. And that one tells you that we have symmetry about the y-axis. So if we drew half of this graph, we would know exactly what the other half would look like because we know that this graph is symmetric about the y-axis. So that's all for this video, a short one, but sweet, and we'll see you in the next video.